Hello friends, welcome to my YouTube channel Ik Onkar Coding. In today's session, we discuss the technique of selection sort. In this, we discuss how to sort the elements in an array using the selection sort. The thing is, in selection sort, we find the maximum or minimum element from the array. The thing is, you can perform selection sort by two ways. One is by finding the maximum element, another one is by finding the minimum element. I explain with the minimum element. So first we find the minimum element in the array. If the minimum element is found, then we place or we swap that minimum element with the first position of an array, that is at 0 index. After that, from the remaining elements, again we find the next smallest element from the remaining elements and swap that minimum element with the second position and so on. Now I discuss this thing by example. So in this example, we have how many elements? In this we have 5 elements in the array: 16, 15, 2, 13 and 6. We have 5 elements here. N has a value 5. It means how many passes required? N minus 1 passes are required. So n minus 1 is equal to 4. 5 minus 1 is 4. 4 passes are required to sort these elements using the selection sort. So first we find the minimum element from this array. So here 2 is the minimum element. So we swap this 2 with the element which plays at 0 index. So 2 and 16 are swapped or interchanged, and after that the resulting array becomes 2, 15, 16, 13 and 6. Only 2 and 16 are interchanged. So this is the output of the pass 1. After pass 1, this first element is in the sorted order. Then we have 4 elements are in the unsorted list. Now again from this unsorted list, we find the minimum element. Here 6 is the minimum element. So we swap this second minimum element with the second index. So now 15 and 6 are swapped. So after completing pass 2, the elements become 2, 6. 6 and 15 are swapped. 6 here, 15 go here. And we have, after completing pass 2, these two elements are in the sorted list. These are in the sorted list. And these elements are in the unsorted list. Now from the remaining elements, again we find the minimum element. Here 13 is the minimum element. Now swap 13 with the element at third index. Okay, that is at second index, because here we have 0 index, here we have 1 index, here we have second index, here we have 3 index, here we have fourth index. Okay, it means this element is swapped with the third element. So after this, the elements become 2, 6 and 13 play in the sorted list, and 16 and 15 in the unsorted list. So after completing pass 3, these 3 elements are in the sorted order. After this, now we find the minimum element from the remaining elements. Now 15 is the minimum element, so swap 15 with 16 and the elements becomes 2, 6, 13 and 15. Now after completing pass 4, these 4 elements are in the sorted list. Now we have only single element. So single element is already in the sorted list, because there is no need to move to further pass for sorting this single element. So here 4 passes are completed and your elements are in the sorted order. Okay, so now we discuss selection sort by using an programming code. So now we discuss the code. Now we discuss by program. So first we include the IOStream header file, then standard packages. After this we include main function. Now I declare an array A of size 20 and represent the number of elements in the array. I and J. I represent the number of passes required to sort the elements. J represent the index of an array. Minimum variable used to find the minimum element from the array. Temp variable is used for swapping the elements in the array. So first we enter the value of n. First we enter number of elements. So using cin object we enter the value of n. Suppose here you input the value of n as 5. After this we enter the elements in the array. So this is just a message that will display on the output screen. After this we implement a for loop. I is equal to 0, I less than n, I plus plus c in a of I. Using this for loop, elements are entered in the array. The thing is how many times this loop is executed. This loop is executed 5 times because 0 less than 5, 1 less than 5, 2 less than 5, 3 less than 5, 4 less than 5. How many times? 0 to 4, 5 times. 5 less than 5 condition false. 5 less than 5 condition false. Okay, so this loop is executed 5 times and 5 elements are entered. After this, now we implement the main code for passes and swapping. So here we implement a outer for loop. Now I represent this outer for loop is used for implementing the number of passes. So this loop is used for the passes. How many passes required? If we have 5 elements, how many passes required? 4 passes are required. If you have 5 elements, if n has a value 5, then 4 passes are required. So I is equal to 0. So 0 less than 5 minus 1, 4. So how many times this loop is executed? 4 times. 0 less than 4, 1 less than 4, 2 less than 4, 3 less than 4, 4 less than 4 condition false. So this loop is executed how many times? 4 times. So 4 passes are implemented using this for loop, using the outer for loop. Now I hope all of you know how to find the minimum element in the array. So I has a value 0. Now a of 0, whatever value contained in a of 0, I assign that value to the minimum variable. The thing is, by using this statement, I am assuming that first element of the array, that is the element which placed at 0 index, I assume the 0 index element is the minimum element. After this, now I implement this inner loop. Okay, now I has a value 0. Now j start from I plus 1, because now I compare this minimum element with all element of the array to find the minimum element. So because there is no need to compare with the 0 index, because in minimum variable we have the element which is at 0 index. So first element is in the minimum variable. Now we compare first element with the second element. So that's why I write here j is equal to I plus 1. J is equal to I plus 1 means 1, because I has a value 0, 0 plus 1, 1, 1 less than 5, condition true. So now if minimum is greater than a of 1, this loop is executed how many times? This loop is executed for 1 less than 4, 2 less than 5, 3 less than 5, 4 less than 5, 5 less than 5 condition false, because we have the elements at last element is at 4th index. There is no need to move at 5th index. So that's why I implemented here j less than n. So now if minimum is greater than, here I implement the if structure. If minimum is greater than a of j, it means this minimum is not the minimum. If minimum is greater, then this minimum is not the minimum. So we update the value of the minimum with a of j. So this loop is executed 4 times. 1 less than 4, 2 less than 4, 3 less than, sorry, 1 less than 5, 2 less than 5, 3 less than 5, and 4 less than 5. So 4 times this loop is executed, and we find the minimum element. After here, if structure is closed, here inner for loop is closed. After this for loop is executed, this inner for loop is executed for finding the minimum element from the array. This loop is executed for finding the minimum element from the array. Now minimum at the starting time, minimum has a value a of 0. Now if this value is updated, if this minimum is updated, then a of 0 is not equal to a, that minimum is not equal to a of 0, that minimum is not equal to a of I. We compare this minimum variable with a of I. If this value is updated, then this condition value is to true. It means this minimum is not equal to a of I. So because this, now here I implement this if structure for performing the swap operation. So now here I use now I write temp is equal to a of I is equal to a of minimum, because now minimum is updated. Now a of minimum is updated. Now I interchange a of minimum with a of I. Okay, so I write here temp is equal to a of I, then whatever value at 0 index, that goes to the temp variable. Now at 0 index, what value go? At 0 index, a of minimum will go. After this, at a of minimum, temp value go. Okay, so in this way we perform swapping, and at 0 position, at 0 index, which element go? At 0 index, a of first minimum will go. After this, this if condition is closed. After this outer for loop is closed. Now before closing this outer loop, now what will happen? Before completing this outer for loop, this I is incremented. Sorry, this I is incremented. So now I becomes 1. Okay, now pass second is executed, pass second is started. Now again, now here in this minimum, which element go? In this element, a of 1 will go. Now first element is placed at right position. Now in minimum variable, which element go? A of 1 will go. Now j start from 2, because 1 plus 1 2. Now we compare a of 1 with a of 2, a of 3, a of 4. Okay, we compare with all elements and find out the minimum element from the array. And after that, we check the condition. If minimum is not equal to a of I, then again we perform the swap operation by using the temp variable. Okay, so both loops are executed for all passes. After this, we display the resulting array. So using this for loop, we display the elements separating by the tab space. After this return 0 and program is ended. Okay, so now we discuss the time complexity of the selection sort. The thing is for finding the, you can also find out the time complexity in this way. The thing is, for finding the minimum element in an array, what is the time complexity? The time complexity for finding the minimum element, time complexity is big O of n. And the thing is, how many times we are finding the minimum element in selection sort? We are finding the minimum element n time, because we have n elements, we have n elements. So we are finding the minimum element n minus 1 times, because the number of times passes are executed, and the number of times passes are executed that number of times we are finding the minimum element. So n minus 1 time n minus 1 passes are executed, so n minus 1 times we calculate the minimum element. So the overall complexity becomes big O of n square. Overall complexity becomes big O of n square. Another thing, another preview is, if you find out the minimum element, another way is, in the first pass how many comparison we performed for finding the minimum element, n minus 1 comparisons we performed. After this, in second pass, how many comparisons we performed? We performed n minus 2 comparison, because first element is in the sorted list. Rest we have n minus 1 elements. And for comparing n minus 1 elements, how many comparison required? N minus 2 comparison required. In a similar way, in the third pass, how many comparisons we performed? N minus 3. In the kth pass, how many comparisons we performed? N minus k. In the last pass, how many comparisons we performed? Only single comparison. So total number of comparisons becomes n minus 1 plus n minus 2 plus n minus 3 up to so on n minus k, 3, 2, 1. After this, there is one formula for finding the sum of all this series. So last element, so n into the number of elements are n into n minus, last element is n minus 1, n into n minus 1 divided by 2. So the complexity becomes big O of n square. Now we discuss some important points about the selection sort. First point is the best case complexity, worst case complexity, and average case complexity is same, that is big O of n square in selection sort, because it doesn't matter your elements are already in the sorted order, the same number of comparisons we perform in all three cases, so the complexity is big O of n square in the selection sort. And another point here I want to discuss with you is, selection sort will be useful when n has very small value, and if your list is already in the sorted, then selection sort is slower than the insertion sort, because here we again in selection sort we find the every time we find the minimum element. But if your array is in the sorted list, then if we perform the insertion sort, then swapping will not perform in that case. So that's why insertion sort is fast in that case. Okay, so I hope you like my video. So thanks for watching my video, and if you like my video, then kindly like, comment, share and subscribe my channel. Thank you all.